Today we're going to be continuing with proofs. So we have proving segment relationships today. We have a couple postulates and a theorem to go through before we get started. So our postulate, we have 2.8, which is the ruler postulate. And that just tells us that the points on any line or line segment can be paired with real numbers, so that given any 2 points A and B on a line, A corresponds to 0 and B corresponds to a positive real number. And so what that's saying is if we have two numbers on a number line, we can put our ruler so that 0 lines up with 1 point and then the other one is somewhere a positive number on that ruler. Okay? The next one, postulate 2.9, segment addition postulate. So that one is just telling us if we have this segment here that I have drawn, and I take these two parts, so I have AB and BC, and I add those together, I'm going to get the length of A to C. Okay? Now the theorems, you've already seen these. You should already have these in your composition notebook. Our theorems, we have reflexive, which is segment AB is congruent to segment AB. We have symmetric, which tells us if AB is congruent to CD, then CD is congruent to AB. So we flip-flop those positions. And then transitive, if segment AB is congruent to CD and CD is congruent to EF, then we know that AB is congruent to EF. Now something to keep in mind here, if you notice, all of these are congruency statements. None of them have equal in them. So whenever you see it going from congruent to equal, we know that there's a step there that we have to do, which is our definition for congruence, which will allow us to convert that to an equal sign. And you'll see that today. Alright, so our first one here, we have our given. We have PQ is congruent to RS. So we have this little segment is congruent to this little segment. And we're trying to prove that P to R is congruent to Q to S. So we always start with our given. So we have PQ is congruent to RS, and that is our given. Okay, and then the next thing we're going to do is some addition. Because we want to get a longer segment, we want to get from P to R and from Q to S. We know PQ, so we're going to take PQ plus RQR, and we have that addition postulate that we just did. So then we can say that those are equal to PQ plus QR is equal to PR. Okay, so then the next one that we have this piece over here, which is our QS that we're trying to find. So we're going to take RS plus QR is going to give us the QS. So RS plus QR equals Q to S. And those were both our segment addition postulate. Okay? Alright, so then the next thing we're going to be doing is just our addition property. We have PQ plus RQR equals RQR plus RS. Okay, so our addition property, so we originally had this in our given, and we know if we add the same thing to both sides, then it remains equal. So that was our addition property. So we added the QR to both sides to keep those equal. So then we're going to do a little bit of substitution here. We have this piece here, we have this piece down here. So we're going to do some substitution. We have the PQ plus QR, and we know that is PR. So we're going to plug that in. PR equals, we have QR plus RS, that's this piece here, and that equals QS, so we're going to put QS. So we took this and plugged in that. We took this and plugged in that. So this is substitution. Okay? Oh, and I apologize here. I wrote congruent. Those are actually just equal to each other. So let's get rid of that. I apologize for that there. Those were just equal to each other, not congruent to each other. If they had been congruent, we would have to first change that using the definition of congruence. Okay? If you have questions on those, please make sure that you're writing it on your WSQ form so that we can address them in class. Alright, so here's the next one. We're going to start with a couple congruency statements. So we have MN is congruent to PQ. So this one is congruent to PQ. And then we have PQ is congruent to RS. So PQ is congruent to RS. And we're going to prove that MN is congruent to RS. So again, we always start out with our given. So MN is congruent to PQ. And then we have PQ is congruent to RS. And those are all segments. And this was given to us. Okay? So then the next piece here, we are wanting to get these from being congruent to being equal. So we're going to say MN is equal to PQ. And I know that by definition of congruence. The definition of it means that they are equal. So we're going to do the same thing for PQ is equal to RS. Okay? So now the next piece here, we're still trying to get MN and RS together. MN is here, RS is down here. So then the next piece that we have, this is transitive. So we can say that MN equals RS because of transitive property. Okay, so we took this piece, and then we put the two together. Okay? So then the last part here is our proof says congruent, and we are at equal, so we have to change that back. So MN is congruent to RS, and that is our definition of congruent again. Okay? Alright, let's look at another one. Okay, so for this one, again, we're going to be starting out with our given information. I apologize, I forgot my segment symbol over the top of two of these. So we have segment JK is congruent to KL, HJ is congruent to GH, and KL is congruent to HJ. And we're trying to prove that GH is congruent to JK. GH is here, JK is here. Okay, so again, we're going to start out with our given. We've got JK is congruent to KL. And we'll go with KL is congruent to HJ. I'm going to stop right there with my given, just because I'm going to deal with this piece first, and then I'll pull in my other given statement. So with this one, I know that I can say that JK and HJ are going to be congruent to each other because of that transitive property. Okay, so I just took out this middle, smushed it together, so I have JK is congruent to HJ, and that is transitive. Now if you notice, I didn't do like I had on this last one. I didn't take it definition of congruence and set them equal and then go back, because we just proved here that even though it says equal, that we can also do it with congruent. Okay, so we don't need to continue doing that once we've proved that that works. So here I just went from my congruency statements to the congruency down here. Now if this had been written as equals, then I would definitely still need to go back to that definition to be able to convert it to equals. So then from here, now I'm going to do my other given statement, which is KL is congruent to HJ. That was also given to us. So then from here, I can use this statement and this statement. Did I do all of them? Oh, I apologize. I wrote the wrong one down. So I already did this one, and I did this one. I needed the center one. Sorry about that. This should be HJ is congruent to GH. Okay. Alright, so now from here, see how these are the same? So now I can say that JK is congruent to GH. Okay, so I'm just taking these two statements and I'm putting them together. And again, that is transitive. Alright, and then the last piece here, they want it written with GH first and JK second. I have it the other way. So now I'm going to be using that symmetric property to be able to flip them. I want GH congruent to JK, and that is symmetric. I flipped those positions. And now I have it written the way that they want it. I have the congruency symbol like they want, and so I'm done. Alright, one more here. So this next one, we have PQ is congruent to RS, so PQ and RS, and then QS is congruent to ST, and then we're proving that P to S is congruent to R to T. So again, we're starting out with our given. PQ is congruent to RS, and we also have QS is congruent to ST, and that is given to us. Okay, so then our next statement, we're going to be converting those so that they are equal signs. PQ equals RS and QS equals ST. Now, I've told you guys that there are several different ways to solve them, so if this isn't the way that you saw to solve it, that doesn't mean that your way is wrong, it just means that it's different. So please understand that there are multiple ways to solve any given problem. Alright, so then from here, we still need to get this PS and RT, so we're going to be adding some segments together, so we're going to do our segment addition. So in order to get PS from P to S, I need to take PQ plus QS equals PS. And I'm going to do the same thing for the other one, for RT. So we have RS plus ST equals RT, and that is our segment addition. So then we have the next one here. We're going to be dealing with our addition property. Which tells us that we can add these different things together, and as long as we add the same thing to both sides, we should be fine. So we have PQ plus QS equals RS plus ST. Okay, so we have PQ, which is equal to RS, and we added QS over here, which is equal to ST, so we put that piece over here. So that is our addition property. We added the same things to both sides so that we kept it equal. Now we're going to do a little bit of substitution. So we're going to take the PQ and QS, which is up here, and we're going to substitute in PS, and we're going to take the RS and ST, and we're going to substitute in RT. Okay, so that's our substitution property. So in the last piece here is this is incongruent, this is equal, so we need to change that. Okay, this is an equal, and we want our answer to be congruent, so we've got to change this piece. So now we're going to put PS is congruent to RT, and that is our definition of congruent. Okay? Alright, that's all for today. I'll see you in class tomorrow.